Hello. So now we'll address the data access layer and we'll describe the data source patterns. Basically, they are used to implement the API that is between the domain logic and the database. And the goal of these patterns is, from a point of view of coupling, is to create a low coupling between the domain logic and the database structure and code, such that the domain logic is mostly independent on the database structure and code. And of course, the different patterns we are going to see provide different levels of coupling. And another aspect that we can look at it is from the point of view of cohesion. And the idea is that all the code that knows how to access the database transaction manager is in this layer, in the data access layer. So it's implemented by these patterns. Okay. So that's the main idea of these patterns. So the patterns that are presented are 4 patterns. And these patterns are table data gateway, row data gateway, active record, and data mapper. And they will go, so data mapper is the one that creates more independence between the domain logic and the database. And table data gateway is the one that does not hide information or doesn't completely hide the information in the database. Actually, in the table data gateway, you see the structure of the database and you receive so you see the tables and the tuples in the tables. You are interacting like in a table. So this actually is the counterpart of the table module that we see in the domain logic. So basically the table module contains the domain logic associated with the table, and this one basically contains the code that knows how to access the database. Okay, and they can be. So that's the first one, and the first one is that basically you have these person gateway. So you have a person gateway, and you have the methods. So you have an API in a Java or in the programming language, and this API, you don't see SQL there, but then these methods are implemented in SQL. But these methods, okay, so you have a single instance, you have the person gateway as a single instance, so it's a table data gateway, so represents a table. So it's a single instance. So every time you refer, you actually are, the operations you are executing here are being executed in the table. So if you are executing the table, if you want to access a particular instance in the table, you should give the ID. Okay, so most of them use the ID. So if you want to update, you just give the ID. Okay. So basically, your code, your business logic code, when using this table data gateway to access the database, basically they are aware that there's a table there, okay? And they are aware of the operations. Of course, the operations you'll see here is the update, insert, so they are the CRUD, create, read, update, and delete operations, okay? So I'm going to repeat this. So if this is integrated with the table module to aggregate the business logic, together with this, then we'll have another one that contains the business logic associated with the table. These are only the CRUD part. Okay. So the next step in terms of complexity is, instead of have a more like object-oriented perspective of it, in the sense that instead of when you do an operation, you have the instances, the instances are represented on your side, because here you don't have the instances. Basically, when you do something here, you get record sets, okay? And you work with these sets, basically. So you work with the table, not the particular instance. So the operations are on top of sets, okay, that represent the tuples in the database. So the other one is row data gateway, and the row data gateway, the difference is that now you have the information, you have an object, the person gateway you have a person gateway for each tuple in the person database. And now, again, of course, the CRUD operations like insert, update, delete are in the person gateway, in the instance. So it's a bit more an object-oriented approach. Of course, now you need to have a person finder so that you can ask the person finder, give me instances of these entity. And they go, so these interacts, so the SQL is hidden here, you interact with the database, you get this information, and then it generates person gateway so that you can interact with. But then you interact with, so you just change the last name or change the first name, and then you just invoke update. So you don't give it's not like in the table data gateway where you need to do the ID that you want to change here. No, you just invoke this entity, it says, please update yourself. And it updates. Of course, all the business logic is outside this entity. Okay. To solve this problem, that you have a more object-oriented point of perspective where the business logic is distributed between the different objects, you have the active record. And what is the difference for the active record? Now, in the active record, besides the code that knows how to access the database, you have your business logic code. Okay, so you have a person. So you don't call it a person gateway anymore because actually is actually a person. So it contains the code that knows how to write and read from the database, but it contains also the business logic. Okay, and the last one, which is the more powerful, because all the ones we have seen, actually, there's a mapping between this structure and the structure in the database. So this person is related with what is in the database. So the person and the table person. You have one that is more powerful, where you complete, so you have your objects in memory, okay? It's a normal object. You don't see here even the API to invoke insert, updates, and deletes. This is in a person mapper, so that's the data mapper. And this third entity is responsible to create a complete decoupling between the person. Now you can see it as a domain model, okay, person, and or domain object, domain entity, and the database. So this means that even the structure where this person is in the database or this entity can be, it doesn't necessarily maps to a table here. So there's a complete independence between this structure and this here. And of course, as we'll see in other patterns, now the insert, delete, and update is completely hidden, in the sense that you don't need to explicitly say save, delete, okay, and insert. Okay, so the system in the background is able so the data mapper in the background is able to check that this object was changed, and automatically when the transaction finishes, writes what is necessary in the database. Okay, so that's the data mapper. So read these patterns and good luck.